Hello Year 8, welcome to the third and final lesson for this week on estimating answers to calculations. If you could please write the title and the date, underline them and have a go at these two do now tasks. Thank you. Right, good. So just looking back at rounding to significant figures, which we did a couple of lessons ago, you should have 8, 50, 600, 4,900, 13, 0.081 and so on. Here are your answers. So just if you've got some wrong, you've probably just not to look at the number of significant figures you should be rounding to, so just maybe go back and have a look at those again if you haven't. And then write a possible question for each answer. So I've written to round 581 to two significant figures, because that would work. I've written round 2,950 to one significant figure. I've written round 12.52 to three significant figures, because I'll get 12.5. And then I've done 0.088 to one significant figure, which would be 0.09, and 5.99 to two significant figures, which would be 6.0. Lovely, yours might be different, that's not a problem, as long as you get those answers. Right, brilliant. Please have a look at the hook questions today. We're going to go straight in. I'd like you to have a go at it before we actually work through the questions, because that might impact how quickly you are then able to go through the video or the PowerPoint. So Sam wants to prepare a new flower bed in her back garden. She's selected an area in her garden that has a length of 8.03 metres and a width of 2.93 metres. A. Work out an estimate of the area of the flower bed, and B. Work out an estimate of the perimeter of the flower bed. Right, lovely. Please pause the video as you have an attempt at this. Right, good. So I'm assuming maybe the first thing some of you will have done is you maybe would have drawn it. So we've drawn what you think it should mostly look like. So we've got our flower bed here, probably worked out that it's about a rectangle because of the measurement. So you've got one measurement of 8.03 metres and one of 2.93 metres. And it says an estimate, and all today's lesson is about estimate calculations, but it's nice to see what you can do at the beginning. So we should know that to find the area of a rectangle, we're doing length times width. That's something we've looked at in year 7. So area equals length times width. So we know that the length is 8.03 and the width is 2.93. Well, let's round them to one significant figure because we want an estimate answer. So that becomes 8, that becomes 3, so we get 24 metres squared. We should know that perimeter is when you add up the distance around the outside. So we do 2 lots of 3 to represent the 2 lots of 2.93 and 2 lots of 8 to represent the 2 lots of 8.03. So you end up with 6 plus 16, which is 22. If you've looked at that and thought, I'm completely unsure what you've done there, miss, you can go back and look at this and have another go at the end, maybe without the answers on, once we've been through today's lesson. Right, brilliant. So our criteria today: bronze to recall how to round to one significant figure. We've done that at the start, so well done. Silver to use rounding to estimate answers to calculations, and then gold is to be able to predict whether or not an estimate calculation will give you a larger or smaller answer than the actual answer. Okay, so first things first, have a think about this. Can you define the term estimation? And then why is it useful to make an estimation before doing a calculation? Please pause the video as you think about these and try and write the definitions down. Lovely, so an estimation is a rough calculation of the value or quantity of something. Okay, so I might say if I go into a shop and Mars bars are 49p and you say how much is 3, I might just, well, I think, well, instead of 49p I'll say 50 and I'll go about £1.50, even though it's a little bit more. Why is it useful? Well, an estimation allows you to determine whether or not your actual answer is within a reasonable range. Okay, does it make sense, your actual answer? So first things first, by rounding to one significant figure, because when you're doing estimate calculations, that's usually what you would do. You would round to one significant figure, estimate the answer to the following. So 110, the first significant figure is the 1, and then it's this one that's in charge if it changes. That's our first significant figure, and the 9 is in charge if it changes. So 110, you'd round to one significant figure as 100, and 49 to one significant figure would be 50. So you get an answer, an estimate answer of 150. Okay, next one. We're doing subtraction here, 76 subtract 21, where you could round 76 to one significant figure, which is 80, and 21 rounded to one significant figure is 20, and 80 take away 20 equals 60. You could check on your calculator the actual answers to those questions as well, because that will give you some insight into how close you get. So we should probably be able to work out that that one here is 159, and this one here is 55. So you can see you're actually quite close when we do our estimate calculation. Right, if you could round each of these values to one significant figure and solve the calculation, please. Pause the video as you do this. Right, lovely, so you should have 40, 160, 200, 160, oh, no answer there, silly miss, so we should have 160 there, brilliant, 20, 50, 10, and 460, lovely. Right, next thing we're going to look at some multiplication. So 11 times 13. Again, if you're good at your calculations, you'll know that you can do 10 times 13 and 1 times 13, add them together. But if you're asked to give an estimate answer, working out the actual answer doesn't benefit you because that's not what you've been asked to do. So we can round 11 to 10 to one significant figure, and then 13 to one significant figure would also be 10. So you get an estimate answer of 100, even though we know the actual answer would be 143. Right, then we're going to round 17 and 34 to one significant figure. So the 17 would round up to 20, and the 34 would round down to 30, and you'd get 600. Right, please have a go at these questions here and pause the video as you do this. Right, lovely, so you should have ended up doing 100 times 10, 30 times 20, 40 times 20, 20 times 10, and 60 times 200, and got those answers. Next, we'll look at some division. So 626 divided by 13, we want an estimate answer to a calculation, so we're going to round them both to one significant figure. So the 626 becomes 600, and the 13 becomes 10, and we get 60. Then we've got 410 divided by 22, we can round that to 420, and then we get 20. Right, please pause the video and have a go at these calculations. Right, lovely, so you should have done 80 divided by 10, 60 divided by 10, 80 divided by 20, 400 divided by 40, 600 divided by 100, and 200 divided by 400. Lovely. Right, we're going to have a look at some non-standard examples. So I'm going to teach you one and then you'll have a go at one yourself. So after a party, each child is given a bag of sweets. There are 17 sweets in each party bag and 37 children went to the party. Estimate the total number of sweets given out. Well, we know the actual calculation is 17 times 37, but we've been asked to estimate. So we round both of them to one significant figure, and we get 20 times 40, which is 800 sweets. Please now have a go at this one in your exercise book. Pause the video as you do it. So James buys 22 bags of satsumas. Each bag has 13 satsumas in it. Estimate how many satsumas James has in total. So there are key numbers. That's our actual calculation, but we want to do an estimate calculation. So we do 20 times 10, and you get 200 satsumas. Well done. Right, another one. So Mrs. Jones has 215 sweets to share amongst a class of 35. Estimate how many sweets each student will receive. This is a sharing question, so it's division. So that's what we're doing, but instead we're going to do 200 divided by 40, because we're rounding both our values to one significant figure, and we get 5 sweets per child. Please now have a go at this question. Pause the video as you do this. Right, good. Cristiano Ronaldo has scored 781 goals in a career spanning 18 years. There are key numbers. Estimate the number of goals he has scored per season. So again, it's a sharing question, a division. So we actually do 800 divided by 20, and you get 40 goals a season, which is absolutely ludicrous if you're a football fan. That's amazing. Right, we're going to look at the decimals now. So again, we're going to round to one significant figure to estimate answers. So the 4.8 becomes a 5 because it's to one significant figure. We know that the 4 is the first significant figure. So we know the 8 is the second significant figure, so that's in charge of if the 4 changes. It's 5 or above, so it rounds up to a 5. So we actually end up doing 5 times 9, which is 45. Then we can do a division. So we're going to round to one significant figure. So here the 7 is the significant figure. Okay, that's our first significant figure. And then the 4 is our second significant figure. So that's in charge of any changes, and it's not greater than 4 because it is 4. So we actually end up doing 70 divided by 5, which we can do quite easily, and we get 14. Lovely. Please have a go at these questions here. Pause the video as you do this. Right, lovely. So you should have done 3 times 8 to get 24. That one's not right, is it? That should be 70 to one significant figure. So you should actually get 700. Well done if you've done that correctly. 5 times 5 is 25. 0.5 times 2 is actually, if you times by half, it's the same as divided by 2, so you get 1. 40 divided by 2 is 20. 10 divided by 5 is 2. 80 divided by 10 is 8. And 200 divided by 20 is 10. Right, brilliant. We're going to look at some more complex ones now. So work out an estimate of the value of the following by rounding each number to one significant figure. So round each number in this calculation, so there are 3 values to round. We've got to round that one, we've got to round that one, and we've got to round the 2.8 as well. So the 6.3 becomes a 6, the 1.2 becomes a 1, and the 2.8 becomes a 3. So actually what you're doing, when you simplify the denominator, 1 times 3 is 3, you're doing 6 over 3, and we know that actually means 6 divided by 3, which is 2. So we found an estimate for the answer. We'll do another one, and there are more things to change. So we've got to deal with the 4.81. We've got to deal with the 3.31 before we square it, not after. The 17.29 and the 8.43. So if we round here, we'd get 5. 3.31 to one significant figure is 3. We get a 20 and we get an 8. Then we can deal with the 3 squared, which is 9. So you end up doing 5 add 9, which gets you 14, and 20 add 8 is 28. 14 divided by 28, you know that you could actually simplify that to a half, because it's equivalent fraction. Okay, so you get an answer of 0.5. Right, if you could have a go at these 3 questions on the right, please pause the video as you do this. It might benefit you from writing down the teacher example as well. Lovely, so your answers should be 5, 2 and 7. So you've hopefully gone 30 here, minus 20 here, divided by 2, and 10 divided by 2 is 5. You've done 7, take away 1, which is 6. 6 divided by 3 is 2, if I just write that up here. You end up with 10 over 2, and then you end up with 10. You'd round that to 5. 5 squared is 25. So you end up with 35 as your numerator. You'd round 4.87 to 5. 35 divided by 5 is 7. Right, brilliant. 30 seconds to think and write down your answers, not share, unfortunately. So I know the square root of 84 is greater than 9 and less than 10. Use your knowledge of square numbers to explain why Mo is correct. Do you think the square root of 84 will be closer to 9 or 10, and why? Please pause the video as you do this. Right, we should remember from previous lessons, even last week actually, that, I always do that, don't I? Square root, the inverse is squaring. Okay, so we should know that 9 squared equals 81. So the square root of 81 is 9. Therefore, we should know that 10 squared is 100. So square root of 100 is 10. And we know that 81 is closer to 84 than 100 is, so it will be closer to 9. Brilliant. Right, can you identify from looking whether or not your answer will be an overestimation or an underestimation based on the rounding you do? So we'd actually round 913 to 900 and 6.42 to 6, okay? So you're rounding both numbers down. That means you're getting an underestimation because the answer you get here will definitely be smaller than the actual calculation because you've made both numbers smaller. Okay, and we can see that here. Have a go at this question. Please pause the video as you do it. State whether your answer will be an overestimation or an underestimation based on the rounding you're doing. Please pause the video as you do this. Right, good, you round both numbers up. So 58 will become 60 and 17 will become 20. Because you've rounded both numbers up, you know it's an overestimation. Your answer to this estimate calculation will be greater than the answer to the actual calculation. And we can see that there by quite a considerable margin actually. Right, true or false? To estimate the answer to 17 plus 163, you would do the following. 20 plus 160. Well, it's false because we know that's right. But to one significant figure, that would actually be 200. Because remember, when we're doing estimate calculations, unless told otherwise, round to one significant figure. The estimate answer to 5.8 squared would be 36, would it? Have a think about it. It would, because you'd round that up to a 6, and we know 6 squared is 6 times 6, which gets us 36. The estimate answer to 525 times 12 would be an underestimation. Well, that's true, because you'd actually round both numbers down, look. You'd be doing 500 times 10. The estimate answer to the following would be 2. Please pause the video, see if you can work this out, take your time. Right, lovely, it says true here, so let's check it. So that would become 2 plus 12, and that will become 7. So 2 plus 12 is 14, divided by 7, that's what you're actually doing. And you do get 2. Well done. Right, the estimate answer to find the circumference of a circle with radius 5.2 would be 15. Now, you should remember from previous learning that to find the circumference of a circle, you have to do pi times diameter. Okay? Now, if the radius is 5.2, what would the diameter be? Well, the diameter is 2 lots of the radius, so let's make that 5. Okay, so therefore the diameter will be 10, so you're doing pi times 10. Pi is 3.14, so you're actually doing 3 times 10, which is 30. So it's actually false. I think it's going to say true, but it's actually false here. Brilliant. Right, here's some practice questions. Have a little look at them. Please pause the video as you work through them, and we'll see what we can do. Right, let's have a look. So Daniel says that estimating the answer to 32 times 55 would result in neither an over nor an underestimation, as one number will be rounded up and one will be rounded down. Why is he incorrect? Well, he's certainly incorrect. It's going to be one or the other because you've changed both of the numbers, because that would become 30 and that will become 60. So just changing the numbers means you're going to get an over or underestimation, and it's actually more likely to be overestimation because of how much you've increased that by as opposed to that. So you could check that to see which one it is. Paul has been asked to estimate the answer to 3.5 squared. This is working out. What mistake has he made? Well, he's done his rounding at the end, and we know we round at the start. So actually you should have rounded that 3.5 to 4 and done 4 squared to get 16. So the answer is just 16. He has to estimate the answer, not round the answer. You do your rounding to significant figures right at the start. Right, Diogo has 362 football stickers and is going to share them with 14 friends. He estimates that they will each receive 36 stickers each. What mistake has he made? Well, what he's done is he's partially estimated, and what he's done is to get an answer of 36, he's rounded 362 to 360, which isn't one significant figure, and he's divided by 10 instead of 14, which gets 36. But that's not quite right, because he should actually be rounding that to one significant figure. So 400 divided by 10 gets you 40. So the mistake he's made is he's not fully rounded the 362. Right, good. This is where we'd use it in real life. So you can see lots of time. We use estimate with time, with petrol costs, with weighing when we're baking. I bet everyone's been baking loads the last few weeks. And when we're in the shops. If you can now complete the worksheet in your workbook and then complete the relevant Hegarty maths tasks, really well done. 3 lessons to get through today, so well done if you've got there. Please get in touch with your teacher if you need any extra help or support. Best wishes, Mrs. Connor.